So we've now seen the one true equation that can be used to calculate the power associated with any circuit element. That's the voltage multiplied by the current. But there are some shortcuts, and in particular, there are a couple of very nice shortcuts associated with resistors. Before I mention the shortcuts to you, I just wanted to take a moment and re-emphasize resistors can never supply power. Resistors can only absorb power. They are passive elements. And in fact, they can only absorb power and then immediately use it by either heating up the resistor or generating some light. They can't even store the power. Some other elements will absorb power and then store it, but resistors, they just absorb the power and then immediately use it. So that's one thing to know about a resistor. The other thing to know is that according to the passive sign convention, because they are passive devices, the current must always flow into the positive voltage terminal. So as we saw in the previous video, the way to determine the direction is point the arrowhead into the positive terminal, and then whatever number results is the power that's being absorbed. Well, we know that that power is going to be positive in this case because resistors can only absorb power. So given that as our sort of preface, the thing to remember is that power is always going to be voltage multiplied by current, but we know that for a resistor, voltage is equal to I times R. Ohm's law. It's the first real equation that we learned in this class. So if I were to take V equals I times R and replace it for V in this equation, then I would come up with I times R times I. So we went from V times I to I times R times I, which is I squared times R. So I squared times R is a shortcut equation for calculating the power, because you will always know the resistance. I mean, unless the purpose of the problem is to calculate the resistance, you will always know the resistance, and then you'll either calculate the current or the voltage. Notice that in this case, we don't have to calculate both. We can just start with the resistance. As soon as we know the current, we can immediately jump straight to the power. We don't ever directly calculate the voltage in this case. As shortcuts go, it's not a massive shortcut, but it could save you a couple steps of work each time that you solve a problem like this, and that can add up. Similarly, we could replace I with V divided by R. You know, we go up to Ohm's law, we solve it for I, we get I equals V divided by R, we substitute that into the equation, so V times I becomes V times V divided by R, which becomes V squared divided by R, and there we have our second shortcut equation. So I squared times R, or V squared divided by R, those are going to be the two equations that will allow you to calculate the power associated with the resistor without having to do the extra step of calculating either the current or the voltage. So just taking a moment to consider the previous example that we saw, we were given that the current was a ½ amp around that whole circuit. It would not have been hard to have calculated that as we saw in that video, but we then had to use voltage division to calculate the voltage across each resistor. Well, technically we didn't have to do that, because if we use the shortcut, I squared times R gives us 6¼ watts for the first resistor, and I squared times R gives us 1¼ watts for the second resistor, and those, if you go back and look at the previous video, are exactly the values that we calculated when we did it the full way. So when we used the full equation, V times I, we got these same values. The shortcut equations give us those same values, but without having to do the extra step of voltage division. So you have enough information now to do the shortcuts for resistor power example problem. Then come back and we'll wrap it up by a discussion of conservation of energy.